Alright, so now we're going to discuss an example on Python. So we're gonna start. I'm importing this, or I'm reading in this data set. It's called cars, and I got this data set from R. They have some really nice data sets. I can show you how it looks like. Right here. So we have two columns. We have the speed and the distance. The speed of the car, and the distance is the distance taken for the car to completely stop. All right. And then I just wrote the f.describe so we can see some statistics about the speed and distance variables. So each of them is 50 for the count, which means they have 50 observations. And these are just some more statistics: the mean, standard deviation, 25th, 50th, and 75th percentile, and so on. So as a data scientist, you might want to ask, how does the speed of the car affects the distance taken to stop? So we can say that, okay, our independent variable, which is the x, is going to be the speed, and our dependent variable is going to be the distance. So we use the speed to predict the distance. So here, in linear regression, simple linear regression, we're trying to connect x and y, and we're trying to do that by fitting a line to the data. So if you remember from high school or earlier, the simple linear equation is just y equal mx plus b, where m is the slope and b is the y-intercept. So linear regression is the same exact thing. Simple linear regression is just going to be the same equation. And we're trying to fit the data to this equation. So x here is going to be the distance and y is going to be the speed. So the first thing to do whenever you have a regression problem is to plot the data. As one of my professors have always taught me, the first thing you have to do if you have any data is to just plot the data, because plotting the data is going to tell you so much about it before even getting started. And one of the main assumptions of the simple linear regression model is that the relationship between the x and the y is linear. And plotting the data is actually going to show us if the relationship between the x and y is linear or not. And we cannot use the linear regression model if the relationship between the x and y is not linear. So here is the code for plotting the data. And when we plot the data, we'll have this interesting scatter plot. And from this scatter plot, we can see that, first of all, the speed and distance are positively correlated. So whenever we increase the speed, we will notice that the distance is also going to increase. So that's one thing. Also, the other thing is, we can notice that actually the relationship between the two variables is kind of linear. So we can notice here that there's like a linear trend. So this is another thing. So if the scatter plot was looking a bit different, maybe from here we could actually observe the linearity between the variables. And if it doesn't look something like a line, then we might not want to use linear regression for that case. So what does linear regression do? How do we fit the line? So basically we just want to draw a straight line between these two variables and that can go through all these points on the scatter plot. But obviously we cannot draw a perfect line that can go through all these points at the same time, right? Because the points are not perfectly aligned. So what regression analysis attempts to do is to draw a line or fit a line to these points that minimizes the vertical distances between each point and this line. So I got that picture from the internet, and this is just two random variables x and y. And as we can see here, there's a line that is fitted to these points, and we can see that there is like a a distance here, or like lines from each point to the line. There's a black line, and this is basically the vertical distance from the point to the line. And regression analysis tries to minimize all these distances. So it's going to pick the line that it's going to make these distances overall the smallest. And obviously it's not only the distance, it takes the square distance, because if we take only the distance, then some distances are going to be positive and others are going to be negative, and then they're going to cancel out. So we take the squared distance and we call that the error, and we try to minimize the error. So that's the basic idea. And obviously if you want to understand more, let me know in the comments below if you want me to have another tutorial about the mathematics behind regression analysis, and if not, then just read about it maybe. And okay, so here basically is the linear regression equation. This is the simple linear, again, because we have one x, one independent variable, and it looks so much like the simple like the linear form or the linear equation. We have y, which is the dependent variable, is equal to beta 0, which is the constant, plus beta 1 x1. And beta 1 here is called the coefficient, and beta 1 here is the most important thing in this equation, because beta 1, first of all, the sign of beta 1 tells us if the x and y are positively or negatively related. So if beta 1 is positive, then they're positively correlated, and if beta 1 is negative, then the relationship between x and y is a negative relationship. And then another thing is that the beta also tells us by how much would the x affect the y. So if we increase x1 by 1 unit, beta 1 is how much y is going to increase or decrease. So we're just gonna do a very simple and fast fitting of the model for the data that we have. So these are all the imports that I have to do, and then we just have to reshape the x and the y. We're gonna use the linear regression model, and then we fit the x and the y, and I'm gonna print the intercept and coefficient. And I'm going to use ypred equal regressor.predict x, which is basically, I'm going to use the regressor that we fitted earlier, and I'm going to use that to predict the new y's from the x that we already have, so we can see actually the fitted line at the end. And I'm going to plot it. So the intercept here is -17, and the coefficient is 3.9. So as we expected, because the relationship between x and y, when we saw from the scatter plot, the previous one, we saw that the relationship is positive, then we also expect that the coefficient of the regression analysis is going to also be positive. And the intercept is just -17. In most of the cases, we don't really care about the intercept. It's just where the line cuts the y-axis. And so from here we can see this is the same scatter plot that we had previously, but now we also have this red line, and this is the regression line. So this is the fitted line, and the equation of the fitted line now is, we can write it down. So we can say it's y equal -17.57 plus 3.9x. And if we want to write that in terms of the variables that we have, so we can say the distance is equal to -17 plus 3.9, the speed. And now I can, for any value of the speed, I can plug it in here, and then this can give me automatically the distance. And that's it for this video. I hope you guys like it. If you do, please share and subscribe and like this video, and stay tuned for more videos.